Morning, good morning, good morning. This is your Captain Shreyas, and welcome to the top 50 questions of mechanics unit, right from your kinematics, Newton's law, circular motion, work energy, momentum, rotation, particles, system of particles, all these chapters. Yes, in this particular session, these are the must-do questions to build your foundation to know that, okay, I understand these topics to make sure that you are at least at some level for your NEET 2025 preparation. So I have collected all these questions just for you, and every day you're going to have 50 questions every subject, 3 sessions every day: physics, biology, chemistry. So 150 questions per day, 7 days will make you reach 1,000 questions plus in 7 days. So that's the challenge, and I can see all of you are fired up for the amazing session with your captain Shreyas. And your captain is going to lead you in this last 2 months, this particular last 2 months for your NEET 2025 to make sure every single student, whether it is a student scoring 100 marks in the mock test or a student who wants to improve from 600 to 700, or whether it's a student who wants to go from 300 to 600, every student will be covered. And you will see the sessions are going to be lined up regularly on the channel. So make sure you are subscribed. Make sure you are liking this video. Thank you so much. Let's begin with the class, all of you. And I just will say hi to everyone on the screen. Yes, welcome. Siva Prasad, Liza, Meghna, Pratibha, Monesh. Nice to see you. Hi, Karthik. Welcome, welcome, Shruti. Welcome, Evening Star. Nice to see all of you. Yes, good morning, good morning. Yeah, the PDF will be uploaded over here. Not just that, the DNA batch for 2026 is also available on sale, and the NEET crash course for 2025 is also available on sale. So in case you want to join the crash batch and get the best offer right now, oh, I think there is a glitch. Uh, Guys, the price was not supposed to be 1,999. It was supposed to be 2,999 because the Vidya Utsav offer ended yesterday at 12 o'clock. So I think by mistake the price has been lowered. So this price I think will change any moment. So yeah, I mean, if you have the chance, make the best use of this opportunity. Okay, because this prices will go up. Okay, so this is the NEET 2025 crash course, which is starting 17th March. Right. So let's begin with the class, my dear students. Coming up on your screen, the first question. Good morning. Good. The velocity time the velocity time relationship is described by velocity is p plus qt square. The body is traveling with what? Now, p and q are some constant. Velocity is dependent on time. Now, this is not any known formula. The moment you look at this equation, you should think maybe I have to do something with this formula to understand whether it is accelerating uniformly, non-uniformly, etc. Or maybe it is not accelerating at all. So what you need to do in this particular question, if velocity is given, to find acceleration, the only possible way is taking the derivative. And acceleration, as we all know, is derivative of velocity with respect to time. So it will be nothing but the derivative of p plus qt square. So derivative of a constant is 0. Derivative of q will come outside because it's a constant. Derivative of t square will be 2t. Hence, I will see that the acceleration is nothing but 2q multiplied by t. That means the acceleration is directly proportional to time. You can see that. So definitely acceleration is not constant. It changes with time. So 100% it should be non-uniformly accelerating, which is option D for your Delhi, AIMS Delhi. Isn't it? Yes, or even Diksha ma'am. Correct. Very good. Awesomeness. Okay, I hope you understood the logic of using derivatives in the question, because this was not a known formula, and to go to acceleration from velocity you always end up taking derivatives. Next question. The velocity graph is shown. The distance traveled is how much in the first 4 seconds. First 4 seconds. This is a direct question. I think you will be able to answer this even if you are an 11th standard student. if you take the area under this particular graph, we know it gives me displacement. So area under velocity time gives me displacement, but the question asked is distance. But the good part is the entire graph is on the positive side, on the upper side. So whatever is the displacement will, the magnitude of it will give me nothing but the distance itself. So it will also give me the distance itself if I take the magnitude of it. So the modulus, mod value will anyways give me the distance. So that means I just have to find the area, which is half, into the base, which is 4 units, into the height, which is 8 units. So 4 into 4 is basically 16 units, which is B option, as you can see over here. How many of you wrote B for biology or B for Baswa sir? Very good. Awesome. Excelente. Many of you got it. Very good, Siva Prasad, Karthi. Excelente. Valvan, Bharti, Partha. Awesome, awesome, awesome. Moving on. Next question coming up on your screen. Keep on practicing with me. I hope you have a rough sheet or some notebook or some pen paper with you. As we discuss, you keep solving. Even if you do not solve completely, at least write down the formula or at least write down the starting few 2 lines so that you know, okay, I can get it. Okay, and it will be best if you can solve it with me and give me the answer. A person walks along the east to west direction street and the graph of the displacement is shown. What is the average velocity for the whole time? I mean, look at this question. Again, a graph-based question. What is the average velocity? Many students will think, sir, I think I will have to take up the area under the graph. I have to take the area under the graph. No, read the question. This is a graph of the displacement versus time. So when the time was 0, that is initially, where was he? The coordinate, x coordinate was 0. If you talk about the final situation, what is the x coordinate? The final situation is, I think, at 19 seconds, when time is 19 seconds. Again, the x coordinate is 0. So this is x initial, this is x final. So if you ask me the displacement, which is final minus initial position, which is 0 minus 0, it will be 0 meters. 0 meters. And what is average velocity? It is displacement by time. So 0 by any number, even a donkey, will be 0. Hence, the answer should be Ames. A for Ames. Is that right? Everybody, very good. It will be a big fat 0. Chumma, it is given in such a way that you will feel, oh sir, you know, there was a big question, there was a big paragraph given. Sir, one crazy graph was there. I thought it will take time. I didn't solve only. But then after the exam, you will be like, oh my God, why did I leave this question? It was such a laddu question. So this is what NTA will do. Unnecessarily, they will make a big paragraph and students will get scared because anyways you are tensed. So much anxiety is there. So you need to overcome that fear by giving lot of mock tests and solving many problems. That fear will go off. Let's go to the next question. Object is going with acceleration, which is uniform, and it is parallel to the instantaneous direction of the motion. How do you think the displacement graph will look like? So the acceleration is in the direction of velocity and the acceleration is constant. How do you think the displacement graph will look like? See, let's understand what it means. Example, the velocity is here, then it means that even the acceleration is over here. And now because of that acceleration which is there, which is constant, this velocity which was there before won't stay the same. It will definitely increase. It will definitely increase. But since this acceleration is a constant, how do I know that? Because it is given uniform acceleration. So this velocity will increase with the equation v is equal to v initial plus acceleration multiplied by time. Therefore, what will your displacement be? Displacement will be nothing but v initial into t plus half into a into t square. Can you see s is dependent on t square? It is a quadratic equation. It is a quadratic equation. Quadratic equation means the graph should be a parabola. graph should be a parabola. It should be a curved line. It won't be like this. This is stupidity. How is this going like this? Okay, but it should be a parabola. Everybody understands this? Yes. So it should be proportional to t square. But the question is very strangely framed. Read the question again. Displacement versus velocity, not versus time. Look at this, velocity, velocity. So students will be like, sir, you know what? New graph came in the NEET paper. Instead of displacement time, they give displacement velocity. Okay, I'll tell you one simple thing. I'll tell you one simple thing. Okay, you guys agree that the velocity is proportional to time, and you also agree displacement is proportional to t square because it is quadratic. So if displacement is proportional to t square, won't displacement be proportional to v square because time is proportional to velocity? If velocity is proportional to time, even time is proportional to velocity. So instead of t square, you can put v square. So it clearly now tells me that my displacement is proportional to v square, which is again a quadratic equation, which means it should be a curved line, which is a parabola. So this should be the graph. Option number C, not D. Many of you said D option, that is wrong. Some of you said A option, that is also wrong. Okay, why is this wrong? Sir, why is this graph not correct? Because this is also curve. Look at this. Look at this, guys. You are saying that the velocity initially was 0, displacement is 0. Again, after some displacement, the velocity is 0. No, how is the velocity becoming 0 again after some time? It is not going to be possible. I mean, you started with 0 velocity, again the velocity became 0. If your velocity and acceleration are in the same direction, the velocity will keep increasing. It will not decrease again back to 0. So that is why this point is the problem. So this can't be correct. Understood, everyone? How many of you loved this question? How many of you loved this particular question? Wasn't it an amazing different model question? That is what we have to do, guys. I mean, don't think whatever, oh, in the textbook displacement time is there, exam also displacement time graph will come. No, no, no. NTA will put anything and you cannot question them. And that is what happened in J means first attempt. Students were not expecting such a crazy thing to happen. And you know the rank inflation is high. So NTA will do every single thing to ensure very few toppers are there in that 700 plus. They will also ensure that people above 650 are less. But don't get scared. So everybody's score will come down, my score will come down. No, so everybody's score is coming down. So the rank is what matters. Even if let's say the topper gets chumma, let's say very difficult paper comes and chumma I'm saying the topper gets 600 marks and you get 595 marks. Like, sure, I got only 595 marks. Does it matter? Maybe you're all in the rank 10, even after getting 595 marks because the topper only got 600 marks. So what matters at the end of the day is the rank, your relative performance. Don't just run behind marks. You have to compete with others. That's what should be there in your mind. That's the exact mistake which many students did last year. They thought, oh, if I get 620, 630, it's good enough. But then everybody thought the same. Everybody prepared well. Everybody got very good marks. So then what you got was not enough. So your relative competition is what matters. Got it? Okay. Next question. A bus starts moving with some acceleration. A cyclist is 96 meters behind the bus and starts moving at 20 meters per second. At what time will he be able to overtake the bus? At what moment? Oh, this is a question on relative motion. Better to draw the diagram. So the bus starts moving. So let's say this is the bus. The bus is right now at rest. The bus will move some, let's say, S1 distance until it is caught by the person. So the person is right over here, or the cyclist. Okay, so that particular cyclist, the cyclist is right over here, and this distance is given to be how many meters? 96 meters behind the bus, and he moves with a constant speed of how much? 20 meters per second, and eventually he will travel some distance S2 and he will end up catching the bus over here. So they end up catching that particular bus over here or overtaking that bus. Catch, overtake, all the things are same. Okay. Now, obviously, you can see from here, this total distance is S2. This total distance S2 is nothing but this particular 96 meters plus this distance, which is S1. So S1 plus 96 is S2. Everybody can see this pure geometry. What is S2? The distance traveled by the cyclist. How much is the distance? Distance traveled is speed into time. So use basically just speed multiplied by time and you will get the answer. So speed is nothing but 20 and the time I do not know is equal to 96 plus S1. Now for this, use your equation, second kinematic equation, ut plus half at square. Why? Because the bus has some acceleration of 2 meters per second square that is given to you. So 2 meters per second square, put it over here. So initial velocity is 0, acceleration is basically 2, time I do not know. That's it. Now I need to basically just solve this particular equation, and let's solve this, guys. Okay, so we have 96 over here, 2 cancels. Okay, so 2 cancels, I will just get t square, and this 20t on the other side will become just minus 20t, and then I of course have 96 is equal to 0. Now this is a quadratic equation. This is your quadratic equation. Chemistry will be at around 8, 9 o'clock. I think the session is not yet scheduled, but it will be scheduled in a bit. Okay, don't worry. Yeah, what do you think will be the answer now? Take the roots, guys. Yes, take the roots. 24 into 4 is basically 96. So basically, you can write it as t uh, uh, t minus or basically minus 24 plus 4. My minus 24 plus 4, you can write it out. Yes, I hope you can see that. But no. I want both the roots as negative. Yes, so uh, it will be basically then I can take which other root will be there, which I can take. Think. Divisible by 8, guys, I can take. Yes, I can take divisible by 8 also. 12 and 8. 12 8s are 96. Yes, that is what I can take. So t minus 12 and t minus 8. That will be better. That will be equal to 0. So basically t is equal to 12 seconds or t is equal to 8 seconds. But we will take the first time. See, both answers are there, 8 and 12. We will take the first time, which is basically 8 seconds. At 12 seconds also he will overtake, but first time he is overtaking at 8 seconds. So I think better to mark B option. Although both are there, I think we should take the first time he is able to catch or overtake the bus. Yeah. Is that clear, my dear warriors? Yeah. Good morning, myself, Sujay. Yeah. Cool. Yeah, it is not option A. It is not option A. Be careful. Yeah. Moving on to the next question. In projectile motion, the physical quantity that remains invariant means does not change. Invariant means it does not change. Horizontal, vertical, kinetic, potential. I mean, this is Laddu question. Let's go. Come on, guys. I want the spam in the chat box. Everybody spam the answer in the chat box. Good morning, Jinendra. Very good, clear, Karthi. Very good, Pratisha. Okay. Yes. Everybody spamming. Anybody who is there who is not saying option A? There is nobody. Very good. It is u cos theta. If this is the velocity, the horizontal component, which is u cos theta, if this is theta, this is u, this will remain constant throughout the motion. And the reason is acceleration in the x direction is 0. Only the y component changes, the x component always remains. So it will always remain u cos theta. That is very, very important. Horizontal component. Next, there is a projectile thrown at 30°. Okay, from the horizontal. It has some range r. Now, if the angle is changed to 60, what is the new range? Direct question. Come on, guys. You should be able to answer within 5 seconds. What is so special about these angles 30 and 60? They are basically complementary angles. You don't even have to use formula. For complementary angles, the range is the same. Range is going to be the same. 30, 60, 45, 45, 20, 70, 10, 80, 53, 37. All these are complementary angles. So if earlier the range was R, now also the range will be R. So option A, range will be the same. Sometimes you will start using the formula. Sir, let me use the formula. Range formula. U square sine 2 theta by G. But even if you use that, you will be like, oh my God, why did I waste my time? I got the same answer. Moving on. A football is kicked with certain speed, certain angle, time taken to touch the ground. So sometimes they give you these direct questions, formula based questions. You should be aware of the formulas. Guys, what's the formula for the total time of flight? 2u sine theta whole thing divided by g. So the formula for the speed, what's the value of the speed? It is 147 sine theta, sine 30, because theta is 30 degrees, sine 30 will be nothing but half, and the whole thing divided by g. G value they have given it as 9.8. Now 2 and 2 will cancel and we will be left with 1470 divided by 98. I've just shifted the decimal. Come on, my dear students, what is the answer for this? What is the answer for this? Come on. 1470 divided by 98, or even if it was 147 divided by 98, do one thing, take an approximate number. See, whenever that calculation is there, you can take approximate number. 147 is like 150, 147 is like 152, 2 anyways got cancelled. 9.8 is like 10, 0 and 0 cancelled. So what is remaining? 15. So answer should be close to 15 seconds. Answer should be close to 15 seconds. Even if you divide it and see, the answer will come out to be exactly 15 seconds. So option C for your Captain Shreyas. Yes, that's the correct answer. Understood how to use your brain in the exam to simplify calculations? Don't sit and, sir, you know what? In the exam, I did this, sir. 98, 1470. Sir, 98 table, I don't know, sir. So, you know what I did? Oh, 98 ones are 98. Then I did this, all that to 98 into 2, 98 into. Guys, it's a waste of your time, energy. Be smart. Get a close answer, and whichever option is close enough, mark it. Why do you want to sit and calculate the exact value? Got it? Don't use that logic of sitting and calculating every single time. Sometimes it is needed, sometimes it is not needed. Okay. If you take a particle moves with some speed, period t, circular path, radius r, speed is double the new time period. Direct question, guys. Come on. If you have a circular path, then the time taken is basically the circumference by that particular speed. Now the circumference is basically 2 pi r, speed is basically v. Now what are you doing over here is that the speed has been doubled. Obviously the time period will be nothing but halved, because this velocity is in the denominator, so time will be exactly half, which is option B. Yeah, you have not done anything to the radius as such. So that is why answer is half. B for Basvasaurus. Yes, Pratibha, smart work always overpowers hard work. Hard work is needed, but if there are two students working the same amount, one person works hard plus he does donkey work. One person works hard but does smart work. Obviously, the person working smartly wins. A person swims in a river aiming to reach exactly on the opposite point on the bank of the river. His speed is given, angle is given with the direction of the flow. What is the speed of that particular river? Okay, so let's draw that particular river. This is one of the bank, this is another bank, and he wants to go directly opposite. That means something like this. He's starting from here and he is trying to go with 0.5 meters per second, but the river flow will pull him over here. This is the speed of the water. W is the speed of the water, and this particular entire angle is given to be 120 degrees with the flow. Remember, the flow direction is exactly this. This is the direction of the flow of the liquid. Okay, so this is 120 and he is able to reach like that. So his resultant velocity is here. This is his net velocity. This is his net velocity, and that is the reason why he is able to go in the shortest path. So my dear students, in this particular problem, what you can do, if this is 120, we know this is 90. So obviously, how much is this? This is nothing but 120 minus 90, which is 30 degree. This is hypotenuse, this is opposite side. So sine 30, which is opposite side, which is W, divided by hypotenuse, which is zero point 0.5. Use trigonometry. So therefore, W will be sine of 30 multiplied by 0.5. Now, what is sine 30? It is also 0.5, and this is also 0.5. So this is nothing but 0.25. Half into half is 1/4, which is 0.25, which is C for Captain Shreyas. How many of you wrote it? Oh, no, it is not A. It is not D. It is C option. Yes, it was given 120 with the direction of the flow. So understand, if this is the flow direction, if this is the flow direction, the velocity which the swimmer will swim, the swimmer will swim is basically 120 degrees. So obviously, if you take it with this particular vertical line over here, with this vertical line over here, how much will be this angle? 30 degrees only. Got it? Because this is 90 degree. This is 90 degree. Understood now? Is it absolutely clear? Uh, Daredevil, understood now? Yeah, so many students make that mistake. Sir, it was 120 degree. Some or the other mistake you will do. Either you will take the velocity here, or I don't know, some other mistake you might do. So, or maybe the diagram only you did not understand. So, be very careful with this river problems, especially when the direction is mentioned with respect to the flow of the river. Assertion reason. This year, lot of questions came in J from assertion reason. In fact, the trend has been also variable. So we might expect lot of assertion reason, statement one, statement two, true, false, incorrect, or just pure theoretical questions also. So let's see one of them. If a body is moving with some fixed velocity, then there must be some presence of net force. Reason, if only net force is there which can change the state of the body from rest to motion. What do you think? Is it the correct reason? And is it actually correct independently? Oh, NEET Express Daredevil, thank you. Nice to see you. And by the way, I'm meeting all the NEET Express and the DNA students today at 4 o'clock. So all the internal students who are already in the batch. So 4 o'clock, I'll be meeting you all. Okay. So because the next plan of action for all of you has to be done. DNA students had one round of complete revision. Now their second round of revision is going to start, and then there will be third round of revision. DNA students very lucky. NEET Express, okay, you joined little bit late, but nevertheless, you are going to start off with the next round of revision. Okay, so all those plans will be shared at 4 o'clock tonight, evening. Okay, so if a body is moving with some fixed velocity, then there must be a net force. Fixed velocity, guys. Read the question carefully. Velocity is constant. If velocity is constant, acceleration is zero. So the net force must be zero. It says there must be a net force. So 100% assertion is not correct. Assertion is 100% not correct. Okay, what about reason? If only the net force which can change the state. This is basically Newton's first law of motion. When there is net force, it changes the state of the body. If it is moving, it can change its direction or speed. If it is at rest, it is bringing in motion. All these things is possible only when there is net force. So reasoning, there is no issue. It is the first law. I think it is option C for Captain Shreyas. Yes, C for your Captain Shreyas, guys. That is the correct answer. Oh no, it is not D. It is not D. Many of you got it wrong. See, that is the reason why you should be a part of these sessions. All these silly mistakes which you are doing, you will try to then avoid. Okay, make many mistakes. Trust me, this is the best problem solving series to kickstart your final leg of preparation. This is just the beginning of the end, let me tell you. Okay, next question. Find the friction on the 5 kg block of this particular system. Okay, okay. Come on, my dear students. Come on. 5 kg, 8 kg, 0.40 friction. Question is force on the 5 kg. First of all, let's assume that both of them are moving together. So let's assume that they move together and see what happens. Move together. Move together. So the total mass of the system will be 8 plus 5, which is 13 kg. And the forces, the net force is given, and that will be the total mass of that particular system into acceleration of that system. So that is 65 is 13 multiplied by acceleration of that system. Therefore, acceleration of that system 65 by 13, that is basically 5 meters per second square. Now what I will do is I will just end up drawing the free body diagram of just the upper block to see what is exactly happening. Well, there is a normal force on it. Well, there is 5g force on it. There will be friction on it to pull it, and obviously it will be accelerating with 5 meters per second square. Obviously, F should be equal to 5 into acceleration. Acceleration is also 5. This is mass. This is acceleration. Force is mass into acceleration. So that should be 25 Newton. So immediately you will be like, sir, acceleration, is it 25 Newton or something like that? Well, you need to see whether it is actually going to be true or not. Okay, we have to see whether it is actually going to be true or not. All right. So my dear students, first of all, if this friction is acting, we need to see if it is below the static friction permissible. And for that, we just can find Fs max. The Fs max value will be mu multiplied by n. Mu is 0.4. Normal force is 5g. Normal force is basically 5g. So it will be 0.4 multiplied by 5. G is 10. So the decimal will go. So it will be basically 20 Newton. It will be basically 20 Newton. Is that right? Okay. Very good. Very good. Till this point, everybody clear? Till this point, everybody clear? Fs max is 20 Newton, but the required friction is how much? 25 Newton. So if this is less than or Fs max, it would have been fine. But the problem is this is right now more than Fs max. What does it mean? What does it mean? It just means that it will slip. It will slip. It will definitely slip because the friction required is more than what it can maximum provide. Oh, so what now, sir? Whatever we have assumed, this particular assumption is definitely wrong. Sir, you went wrong, sir. What did you do? Don't worry. That is how you should solve block on block problems. You always assume something, get the result, and compare it whether the conditions are matching. If it is not matching, then you have to say, oh, my assumption is wrong. That means they slide. So therefore, there is relative slip and kinetic friction. Kinetic friction is mu into n. So if you do that value or find out that value, it will be again 20 Newton. So the answer will be basically 20 Newton. The answer will be basically 20 Newton. Understood? It will be constant. Remember, kinetic friction is always going to be a constant value. Remember those graphs. Fs max keeps on increasing, then Fk is a straight line. That means it does not change. Now, I think the options went wrong over here while printing. I think 10 was more. So the I'll just remove this. Okay, these zeros. Okay. So I'll just create a slide over here and say this is the correct answer. Option D is the correct answer. Understood, guys? Everyone clear how to solve this block on block question? Very good question it was. Okay, great. So let's move to the next question, guys, coming up on your screen. Okay. If a force of constant value magnitude is in the direction perpendicular to the motion of the particle, what happens? Everybody should spam the answer. When would 25 be correct? Okay, So for the previous question, 25 would be correct. For example, Chumma I am saying, just say for example, this value was, let's say, 0.6. Let's say this was 0.6. Chumma I am saying. So what will this be? 0.6 into 5g, 0.6 into 5 into 10, 6 5s are 30. So this would be then 30 Newton. This would be then 30 Newton, correct? Then our required friction is less than the limiting friction. So it is allowed. So it is okay. Nothing is wrong. So requirement is less than the limit. So whatever my assumption is there, that will be correct. They are moving together. Then the answer would have been 25 Newton. Is that okay? Everyone understood? Yeah. So I have told you both the variations. That is how you should solve the problems. By the way, we have to solve all these kind of questions, and that is what we intend to do in that last revision phase also, where all kinds of variations. Sir, what will happen if this happens? And that is why I feel live classes are more important than recorded classes. Okay, because what happens is when you ask me doubts in any batch or any series, I will try to answer it then and there, and we clear your doubt then and there itself. And then you solve 2, 3 new problems because of that one question. Okay, what about this? Yes, option A should be correct. I think Ninja, Malesh, very good, very good, very good. Clear. Option A, why? Speed is uniform. Reason, whenever our force is perpendicular to velocity, then the work done is zero. Change in the kinetic energy is zero. How did I get that? Work, kinetic energy theorem. That is what it is. So if there is no change in kinetic energy, therefore the speed should be a constant. Speed should be a constant. That is the logic behind it. Hence, speed is uniform. That is the correct answer. All right, moving on to the next question. On your screen, start reading it. Oh, Gopika ma'am is here, and Gopika ma'am is scolding already. Why have we not reached 200 likes? Ooh, what is this? 200 likes not reached, huh? Come on, guys. Quickly smash that like button right now. Yes, this is a session for all of you. You cannot just consume the videos without not giving that Guru Dakshina, or else whatever you learn in this session will never enter your head. Guru Dakshina, believe it or not, always works. Okay, and that has been a tradition for ages, centuries, right from Gurukul times. And you should always make sure you're giving it back to your juniors, to your teachers, spreading the word. Oh, this channel is there. Oh, sir, thank you so much. You have to always put a comment, like every single teacher, every single session, because you have learned from that session. All right. All right. Let's move to the next question. There is a coin on a rotating table just slips when at distance 1 centimeter. If the speed is half, it will slip at what distance? So see, the diagram will look something like this. If this is that table which is basically rotating like that, and you have this particular coin box, whatever this particular mass is there, there will be many forces on it. But the main force that you should talk about is the centrifugal force. The centrifugal force, which will be outwards, which will be balanced by the frictional force, and it will prevent it from slipping. So when it is on the verge of slipping, on the verge of slipping, you will see Fs max will be centrifugal force, which is m omega square r. Okay. Now, what is Fs max? It is mu into normal. Normal is nothing but mg. So it will be m omega square r. Cancels. Therefore, I will get mu g is equal to omega square r. Now, in this particular problem, the speed is changed, distance is also changed, mu and g are not changed. So, since mu and g are still the same, it is basically omega square r, which is the constant. So, firstly, it was omega. Next, it is the new omega which is there. That new omega is how much? It is half. So, it is basically omega by 2 whole square. I will get the new distance. Omega square will cancel. R will become 1 by 2 square is 1 by 4. are new. So therefore, the new distance will be 4 times of the old distance. The old distance was 1 centimeter, I believe. So this answer will also be 4 centimeters. D option. Is this absolutely clear, my dear students? Yep, very good. The answer is 4 centimeters. Very nice. D for doctor, D for Delhi Ames. Great. Let's go, guys, to the next question on your screen. Okay. Car is moving, horizontal circular track, radius is given, speed is constant, coefficient is given. What's the speed of the car? Remember, whenever you have a horizontal track, the speed is given by root mu rg formula. This is the maximum speed permissible. So, this is the maximum speed permissible. So, mu is nothing but 0.45. Radius is basically 0.2 kilometers. So, multiplied by 10 to the power 3. Or you can just say it is nothing but 200 meters and multiplied by g, which is nothing but 10. So if you multiply by 10, this will become 4.5. 4.5 into 2 is basically 9. So it will become root 900. That means it will become 30 meters per second. So 30 meters per second, that is basically the maximum speed of the car. So it can be anything less than that. The speed of the car may be, it can be 30, it can be 20, it can be 15, but it cannot be 40. I think the manner in which the question has been framed is slightly wrong. The manner in which the question has been framed is slightly wrong. The question should have been can't be. The Because you cannot mark 3 options, it is not J advance. All the 3 speeds are possible. This is a maximum speed permissible. This question could have been can't be. This question should have been the car can't be. The speed of the car can't be. And the answer for that would have been this particular option, D. Is that clear? Then it would be D option, because otherwise all the 3 options could have been possible. It can be lower than the maximum speed. Cool. Shall we go ahead? Awesome, my dear students. Let's move. Let's move to the next question. Here it is. There is a kid whose mass is 25. He's sliding down a rope from the branch of a tree. The force of friction is 2000. This kind of question. Monkey sliding, fireman climbing on the rope, kid is sliding, person climbing. All these kind of questions. Every time free body diagram students make a mistake. The friction is 200 Newton. Acceleration is how much? Okay. So let's first of all think of a rope over here. So let's say this is the rope. Okay, let's also think about that kid. Okay, so this is our kid over here. Hmm? Great kid, Pandu kid it is. Okay, so this kid is sliding down. Kid's mass is also given. And the force of friction against him is 200 Newton. The acceleration is how much? So let's draw the forces. What are the different forces? His own weight will be there, right? His own weight. How much will be the weight? mg. Mass is 25 and g. So it will be basically 250 Newton. He is sliding down. So friction will act against him. That means friction should act upwards. So this is basically the friction. And how much is the friction? 200 Newton. He is going to accelerate down like this. So I can then say the weight minus the friction is mass multiplied by the acceleration. The weight, how much is the weight, guys? Come on. How much is that particular weight? Weight is 250, friction is 200, mass 25, acceleration find out. So therefore 250 minus 200 is basically 50, is 25 multiplied by a. So 50 by 25 is nothing but 2 meters per second square. So the acceleration should be D option. Yeah, understood? Very good, very good, very good, very good. Oh, they have given 5, that is wrong. No, it is 2 meters per second square, guys. They have marked the wrong answer. So I'll just correct it over here and I will write it as 2 meters per second square. Is that clear, everyone? Very good. Excellent. Awesomeness. Moving on. Yes, mg minus a. Pratibha, I'm not sure which formula you have used. No, I think you have used some lift formula. No, don't use that lift formula. I'm not sure why you have used that. Don't use that. Just go with the free body diagram. Usually these monkey problems, fireman problems always work like that. Next question. In the arrangement shown, all surfaces are smooth. What acceleration should be given for the system so that M2 does not slide down? Wow, M2 should not slide down. Then what should be the acceleration given to the particular system? All surfaces are given to be smooth. See, if it should not slide down, the entire thing should move together. So the complete system moves moves together moves together, right? Moves together with with acceleration, with some acceleration. Let's assume it as a. Let's assume it as a. Okay, so let's draw the free body diagram of some bodies over here, like for example this mass m1 over here, and then the forces acting on this particular m1 are, obviously there is a tension over here, and if you look from the ground frame, obviously it is going like this with that acceleration. Obviously there is normal force, there is m1g force, all those are there, but in horizontal direction only tension is there. So I can immediately say T is equal to m1 multiplied by a. Everybody, tension is nothing but m1 multiplied by a. Awesome. Next, if you look at this particular mass, well, there is a normal force from here. Obviously, this is accelerating with the entire thing like this. There is a tension over here, and its own weight is there, which is nothing but m2g, which is nothing but m2g. So obviously, again, I can say by m1 and the whole thing multiplied by g, which is option number A. Is that clear? Everybody with me? Just drawing simple force body diagrams has led me to the final answer. No, it is not D. It is option A. Yeah. Thanush Kumar, I hope you got it. Milesh, just refresh. Maybe the lag should go off. Okay. Moving on to the next question. The moment of inertia of a disk of radius 0.5 meter about its geometric axis is 2 kg meter square. If the string is tied to the circumference and a force of 10 Newton is applied, then the angular velocity after 2 seconds. I think drawing the diagram is the best thing to do. So let's draw the diagram. This is that wheel. It has a moment of inertia given by 2 kg meter square. It is hinged over here. And then what you are doing is you are up putting a rope over here like this, and you are pulling it. How much is the pull? The pull is 10 Newton. So that pulling force is basically 10 Newton. And the radius of the disk, is it given? Yes. This particular radius is also given, which is 0.5 meter. Okay, after 2 seconds, what's the velocity? See guys, because of that pull, there will be an angular acceleration. Yes, there will be an alpha. I think finding the alpha is the top priority now, and we can use that the net torque acting on a body is moment of inertia into alpha formula. Torque is R into F, R multiplied by F. So R is basically 0.5 meter. The force is basically 10. Moment of inertia is 2. So into alpha. 0.5 into 10 is just 5. So this is 2 alpha. So alpha is nothing but 5 by 2 radian per second square. But that is not the end of the story. Finding the velocity after 2 seconds, I will use kinematic equation on circular motion. Final velocity is initial velocity plus alpha into time. It was at rest, so 0 velocity. Alpha is basically 5 by 2. Time is 2, so 2 cancels. So I will get 5 radian per second. That is the final angular velocity, which is B option. Is that right, everyone? How many of you wrote B? Got it? Two formulas, two concepts are involved over here. One is the concept of torque with relation and its relation with alpha. And the second concept was the kinematic equation. So without doing this, we cannot solve this. So you should think in the reverse. I have to find the final speed. So for that, I need the initial speed. Oh, it was at rest. Okay. I need it after some time, so I can use kinematics. but I don't know the acceleration. Oh, how do I find the acceleration? Maybe drawing the diagram will help. So always diagram is very important when it is not given. It gives you some clear picture and clarity. You cannot always visualize in your head. So if your visualization is moderate, average, not so great, or you might make some silly mistake, better to draw it in the rough work. Don't think it is a waste of time. In fact, you have to make it a habit at home only so that you become really fast about it. Okay. In the arrangement shown, the mass m will ascend with an acceleration. Mass m will ascend. Ascend means it will go up, descend means it will come down. So ascend is going up. Okay, come on, think about it. What acceleration will it go up? The force is already given. So this clearly means whatever this force is there, that will go as the tension in the string. The force with which you are pulling it, the pull will be the tension. So the tension in the string will be nothing but 3 mg by 2. Obviously, there is mg over here. So this is more, this is less. So bigger force, 3 mg by 2 minus smaller force is nothing but mass multiplied by acceleration. This is nothing but half. 3 by 2 minus 1 is half. So mg by 2 is ma, cancel. So acceleration is g by 2. So g by 2 is B for Basvasaurus, sir, or B for biology. Yeah, very direct question. The main concept here was this force is going to manifest itself as the tension. Whatever you pull, that pull only will be the string's tension. And remember, in an ideal massless light string, the tension throughout the string is the same. So that is why the same tension will go on to the other side. Okay, so that's the answer. Moving on. Assertion reason. The bullet is fired from a rifle. If the rifle recoils freely, then the kinetic energy of the rifle is more than that of the bullet. The kinetic energy depends on the mass directly by the formula half mv square. Oh, very interesting question. See, we know that the momentum is conserved. We know that the momentum is conserved. Whatever momentum is there of that rifle will be there of the bullet. So momentum of that rifle will be the momentum of the bullet because it has to be conserved. Because since the net momentum is going to be zero and it is going to be conserved. But how is it then related to kinetic energy? We all know kinetic energy is square of the momentum by 2m. Using this formula, the one which has more mass will have less kinetic energy. So bullet rifle recoils. Rifle is usually heavier, so the kinetic energy should be less. Oh, it is said more. If the rifle recoils freely, the kinetic energy of the rifle is more than that of the bullet. Wrong, guys. The one which is heavier, the one which has more mass, will have less kinetic energy. So assertion is wrong. Everybody clear? Everybody clear? Okay, assertion is incorrect. Kinetic energy depends on the mass by the formula this. Oh, this is correct. There is nothing wrong in this. So assertion is incorrect, but reason is correct. So option C, guys. Option C, I think they have marked it wrong. So option number C should be the correct answer. Option C should be the correct answer. Is that okay, everyone? No, nothing wrong with the reason. Kinetic energy has a formula half mv square. That's a standard formula. Cool. Moving on to the next one. Body is acted upon by a force which varies as shown in the graph. The momentum acquired is, come on, my dear students. Force versus time graph is given. We all know that the area under this gives me impulse and that can give me the change in the momentum. So we all know impulse is area under force versus the time graph, and impulse is final minus initial momentum. Area under the graph is the area of the triangle plus that rectangle. So area of the triangle is half multiplied by base multiplied by the height, which is basically 10 units. So this is the triangle plus area of the rectangle. So 6 minus 2 is 4 and the height is basically 10 units. So this is for that rectangle. Okay. So from this final momentum minus initial, body is acted upon by that force. Okay, how much momentum does it acquire? Initially, it had no momentum. 2 cancels, so this will become just 10 plus 40. So therefore, the final momentum will be 50 kg meter per second. Or you can also say the other unit is Newton second. 50. Yes, option D, guys. Option number D. Everybody understood? Yeah, D for your Delhi, D for doctor. Perfect. Awesome. Let's go to the next question. Very good question. On the area under force time graph gives you momentum change, which is also called as impulse. Gravel, oh, gravel is dropped. Okay. Gravel is, first I was thinking grave is dropped. I was like, that L was not looking nice. Why would somebody drop a grave? That would be scary. Anyways, so a gravel is dropped onto a conveyor belt at some rate 0.5 kg per second. Extra force is required in Newton to keep the belt moving at 2 meters per second. Okay, let's see. What is this? Pratibha, you also felt the same, right? Okay. So the logic to solve this question, force is rate of change of momentum dp by dt, dp by dt. Momentum is mass into velocity. If rate of change of mass is given, take that velocity outside, so it will become v into dm by dt. Velocity is 2. dm by dt is rate of change of mass 0.5. What is it? 0.5 kg per second. So 2 into 0.5 is 1. So 1 Newton should be the answer, option A. That's it. Very different quality of question, pattern, model of question. Solve more times these kind of questions. If you have solved this, say force is given, can you find velocity? Say velocity and force is given, can you find the rate of change of mass? All these type of questions you should be able to solve. You solve one question, solve two more questions on that. That will give you that confidence. Acceleration of the mass, when the acceleration of the mass is as shown. Ayo, what is the acceleration of the mass and the acceleration of, why do they frame such nice questions? Right? Students will be like, am I reading this correctly? What is the acceleration of the mass when the acceleration of the mass is as shown? So this guy's acceleration is given and this guy's acceleration is asked. Okay, so don't get confused, guys. So now let's see how do we solve this particular question. Okay, let's see how to solve this particular question. So first, draw the free body diagram of that particular 2 kg mass. Okay, so we have that 2 kg mass. There is a force of 10 Newton on it. There will be obviously some spring force and it has some acceleration of 2 meters per second square. So I can say 10 minus Fs will be mass into acceleration. So therefore, our spring force will be, take it on the other side, it will be 10 minus 2 twos are 4. So I think it will be 6 Newton. Spring force will be 6 Newton. Why is this needed? Now we'll draw the free body diagram of that 3 kg mass. The only force acting on it is spring force and that will have that acceleration because of that. So that spring force will be mass into acceleration. Spring force is 6. So 6 is 3 multiplied by A. Therefore, A is basically 2 meters per second square. 2 meters per second square. Yes, option number B is the correct answer. Everyone? Very good. Yeah. The mass will be constant and we can only conclude that kinetic energy is directly proportional to V square, right? How can we talk about mass there? The mass will be constant and we can... No. Acha. So let me just show you that particular question. Where did we go? So in this question, if you talk about individual particles, I'm talking about individual, not the total system. The particle or that body which has more mass has less kinetic energy by this formula because the momentum of both the bodies is the same. That was the assertion part. Now for the second part, it is a general statement saying kinetic energy depends on mass directly by the formula given by half mv square. How is kinetic energy dependent on the mass? It's just telling about that, nothing else. And yes, this formula is definitely correct. It also depends on velocity, but it is just mentioning how it depends on the mass with this formula. So definitely it is correct as a formula and the relationship between mass and kinetic energy. It's not saying whether mass is constant, whether mass is increasing, or whether mass is being split. Nothing it is saying. As a statement, there is nothing wrong in it. Is that okay? Okay. No, velocity is not the same. Velocity will be also different. Okay, tell me one thing. Okay, just imagine this was our rifle. Okay, this was the bullet. Now the bullet came outside, so that rifle will have a recoil. Now, in this particular example, let's say the mass of that rifle is 100 kg, example, okay, and the mass of that bullet is, let's say, 20 kg, is 20 kg. So just imagine this, if these are the masses, or even let's say I can just put it as 1 kg also. In this particular example, do you think the velocities will be the same? No, right? In fact, the momentums are same. So the momentum of the bullet will be mass into velocity. Let's say the velocity is, example, chumma I'm saying 200 meters per second. So it will be 1 into 200. But if you talk about the momentum of that rifle, mass multiplied by the velocity from this will come out to be 2 meters per second. So this particular velocity comes out as 2 meters per second, which is less. Obviously, the speeds are different, but as you can see, the momentums are going to be the same, because initially, 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 the total momentum was 0. So therefore, afterwards also, the total momentum of that system should be 0. So therefore, the net momentum finally should be also 0. That's why they are equal and opposite. Is that now clear? Is that now clear? Siva, don't spam. I got your question. Clear? Yeah. Pokey, it's not so easy if you start from now. And when you say I'm starting from now, what do you mean by starting from now? Are you like starting from zero, or are you starting from somewhere 300, 500? If you are at 500 getting 650, definitely possible. If you are saying I'm starting from zero and can I get 650, I don't want to be that person who tells you that truth, but obviously you are going, if you are planning to become the doctor, you know that when some patient comes and if there is some serious illness, you have to tell that patient, oh yes, listen, you are ill, you have to take this medicine. You cannot say, oh no, you will be perfectly fine, and the patient goes dancing out, and then the patient will be like, what the hell, you told me I'm perfectly fine. So when I'm telling you, if you are starting from zero, getting 650 in 2 months, it is a serious business. I mean, then it will be a joke on all the students who have been taking drops and practicing very hard. I would say, please try your best to get at least till 300, 500 marks or 400 marks and take a drop properly and study for the next year. If you're already at 4, 500, you can definitely reach to 650. I mean, you have good 2 months of time. Why not? A particle moves from this point to this point by this force. How much work has been done? Yeah. Come on, my dear students. Come on, my dear students. Think about it. How are you going to solve this particular question? Displacement you have to find. Force is given. Work is force dot product with displacement. That's all. So displacement is final minus initial. So 4j plus 3k minus 2i plus 5j. So this will become 2i cap. 4j minus 5j will become minus j plus 3k. So that is your displacement. So now finding the work now. Now trying to find out the work. So work will be force dot product with displacement. So force is 4i plus 3j dot product with 2i minus j plus 3k. Remember, I cap multiplies with I cap. So 4 twos are basically 8. J cap multiplies with J cap. So it will be minus 3. K has nothing to be multiplied. So 0. So it will be just nothing but 5 joules. So 5 joules is option number A. 5 joules is option number A. Got it? Very good. Yeah, you just need to find the displacement and then go ahead. Moving on to the next one. Position depends on the force acting on a particle and the force curve is given. What is the work done on the particle when the displacement is 0 to 5 meters as shown? So 0 to 5 meters, work done is nothing but the area under the force displacement graph. Area under the force versus the displacement graph. If you notice clearly, this is a trapezium. For the trapezium, the area is nothing but half into the sum of parallel sides multiplied by the height. So this is one side whose length is 1 unit. The other side is having a length of 3. The height is basically 10. 1 plus 3 is 4. 4 by 2 is 2. 2 into 10 is 20 units. Similarly, try to find the area of this particular trapezium. Again, half into sum of parallel sides. This side 3 to 5 is 2 units. This side is just 1 unit. Height is again 10 units. 2 plus 1, 3. 3 by 2, 1.5. 1.5 into 10 is 15 units. But remember, this answer will be negative because it is below. So the question is on the total work done, which is area, which will be 20 minus 15, which is 5. Hence, the answer should be basically 5 joules. 5 joules. Is that okay? Clear? Whatever is below is negative area. Whatever is on the top is the positive area. Very nice. Option D, correct answer. There is a block of mass m pulled along a circular arc by means of a constant force as shown. Work done by the force in pulling the block from A to B is how much? How much work has that particular force done? Okay, come on, my dear students. What do you think will be the answer for this? See, this force is constant, right? Going from here to here. Just check how much displacement has happened in the x direction because the force is also in the x direction. So that work will be the force into displacement in the x direction. So displacement in the x direction. Well. As you can see, over here, this distance is r, which is the hypotenuse. That is basically the hypotenuse. So if I want to find this particular distance, which is the displacement in the x direction, it is r sine 60. It is r sine 60, which is r root 3 divided by 2. So just put r root 3 by 2. So fr root 3 by 2. I think option C should be correct. Yes, it is the correct answer. So r root 3 was the distance. So fr root 3 by 2, which is option number C. Is this okay? Very simple question. Just take the displacement. Don't carry out the calculations for distance. This arc chumma given. No need of that. Only the displacement in the direction of the force. What was work? Force into displacement in the direction of the force. Okay? I hope this is clear. If you can get above 98, definitely you will be a part of the Ekalavya batch for JEE Advanced, definitely. Next one, identify the correct statements. Read it all. Come on, I want everybody to read all the statements. It's all about work done by the man, work done by the gravitational force, work done by friction, work done by applied force, work done by air resistance. Come on. Identify the correct statement. Work done by a man in lifting a bucket of water out of well by means of a rope tied to the bucket is negative. No, this should be positive, guys. This is not negative. This should be positive. So this is wrong. When you're pulling it up, force and displacement are in the same direction. So it should be positive. Work done by gravity in lifting the bucket out of the well is negative. This is correct. Nothing wrong in it because the force and displacement are in the opposite direction. Work by friction on a body sliding down an incline is positive. This is wrong again. How is it positive? This is, yes, this should be negative. Okay, so C is also wrong. Work done by force on a body moving on a rough plane with uniform velocity is 0. No, it is not 0. The work done by applied force, it will be there. You are doing some work, you are pushing it. So it has to be positive, right? You're pushing that body on a rough surface. So it has to be there. So work done by air resistance on an oscillating pendulum is negative. There is nothing wrong in it. Obviously, the air resistance which is there, it will suck away the energy. So it will definitely do negative work. So B and E only, which is C option. Which is C option. Check it out. B and option E. Yeah, B option. Very good. How many of you got it? Very nice. Awesome, guys. Awesome. Let's move now to the next question on your screen. Okay. If a man increases his speed by 2, his kinetic energy is doubled. What is his original speed? This is a very good question. Let's try to solve it. The person increases his speed by 2, the kinetic energy doubles. What do you think is his original speed of the man? So let's assume the original kinetic energy to be K, the original mass to be M, and the speed was some V. So K is half mv square. The man has increased his speed by 2 meters per second. So now we'll talk about the new kinetic energy, which will be double. So this has been doubled. This has been doubled. And all of this has happened because the speed has been increased just by 2 meters per second. Okay. But I already know what the original kinetic energy formula is from here, which was half mv square. So I'm just substituting k over here as it is, doing nothing. Okay, this is equal to half mv square plus 2 square will be 4 and 2 into v into 2. So 2 into 2 is 4. So this would have been 4v, not 2v. Okay, now half m will cancel. So I will just get 2v square is equal to v square plus 4 plus 4v. Now what I will do, I will bring all these people over here. So 2v square minus v square is just v square, and this will be minus 4v, and this will be minus 4. Is that right? This will be equal to 0. Just check this out. Yeah, correct. Yes, 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 yes. Perfect. Now we will take the roots by taking v is equal to minus b. B is minus 4 plus minus root of b square, which is nothing but 4 square, which is nothing but 16 minus 4 into a into c. C is nothing but 6. C is nothing but minus 4 over here. The whole thing divided by 2 into a. Okay, so this will become minus will become plus. Okay, this minus will again become plus. 4 4 is 16. 16 plus 16 is nothing but 32. So 32 will come over here divided by 2. So 4 plus minus 32 is 16 into 2. 16's root is 4. So 4 root 2, whole thing divided by 2. So this will be divided by 2. So 2 plus minus 2 root 2. But ignore that negative root. Ignore that negative root because then the value of velocity will be negative. So that is not possible. That is not possible. So the only allowed value will be the positive value. So the velocity should be 2 plus 2 root 2. 2 plus 2 root 2, which is option C, I believe. Yes, option C is the correct answer. Is that okay, everyone? Very good. No, D is not correct. C option, C option, C option. Yeah, be careful. Be very careful. No, it is not D option. That 2 plus 2 root 2 is also there. There's 4 will come outside. So after cancelling 4 with the 2, 2 will remain over here. So do not forget that 2. So that is why option C will be the correct answer. Got it. Very good, Ninja. Awesome. Moving on to the next question on your screen. A simple pendulum with a bob of mass m oscillates from A to C and back to A such that PB is height h, acceleration due to gravity is g, then the velocity of the bob as it passes through B is how much? Guys, direct energy conservation. Come on, direct energy conservation. Here you have zero kinetic energy, but you have mgh potential energy. Is that right? Here you had zero kinetic energy, but mgh potential energy. So over here, all that got converted into kinetic energy, and you have zero potential energy. Use energy conservation. Use energy conservation. Kinetic energy was half mv square, and your potential energy over here was mgh. Cancels, so you just have to find v, right? So gh will be v square by 2. Therefore v will be root of 2gh. h. Root of 2gh. That is the answer. Root 2gh is the correct answer. Is that absolutely clear? The entire potential energy got converted into kinetic energy. So, direct question. Okay. Uh, I can't be so sure pro cuber if it is going to be free or not, but usually the cost will be very minimal if you are above 98 percentile or as good as zero only. But that needs to be seen. See, this time we had kept that offer for January attempt students that if you are getting 98 and above, then we are giving the Ekalavya batch for free. And if you are close to 95 and all that, the prices were very minimal. So that needs to be seen. Okay, I cannot comment on it right. The equilibrium position of a particle moving in the potential field as shown in the figure will be at equilibrium. Equilibrium happens. Where do you think equilibrium happens? When the slope is zero. When the slope is zero for the potential energy graph. Here I can see the slope is zero. Here I can see it is zero. So whenever the slope is zero, then the force is zero. And that is when you will see the equilibrium. And that is happening at x equals to 1 and x equals to 2. X equals to 1 and 2, that is the answer, which is option number C. That is option number C. Is that clear, everyone? Awesome. Very good. Kudos to all of you. Moving on to the next question on your screen now. Convert the graph into force graph. Convert this energy graph into force versus displacement graph. Okay. See, I'll tell you what. The force value is always negative du by dx. This is the concept. So now, for this part, the du by dx, can you see the slope of this graph is constant. So for this part, I can say du by dx, which was the slope, was a positive constant. It was positive constant. So therefore, the force will be a negative constant. The force will be a negative constant. Till this point, everybody clear? Yes, sir. What about this part? In that particular part, the slope is zero. So if the slope is zero, du by dx is also going to be zero. So the force will vanish. It will be zero. So it should be negative and then become zero, not positive and then becoming zero. I think this is correct because I can see it is zero over here. And in the initial part, it is a negative constant. So for some duration, it is negative constant, then it becomes zero. So option A is the correct answer. Is this clear, everyone? Yes. Very good. Very good. Very good. Awesome. Great. 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 Yeah. Very nice. Moving on to the next question coming up on your screen. Two protons moving towards each other, then the potential energy will be, if two protons are going towards each other, then what will happen to the electrical potential energy? Two positive charges, they never like each other. So what will happen when they don't like, their potential energy will keep on increasing? Yes or no? It will just keep on increasing. Definitely yes. The correct answer is increase. Very good. Very good. Moving on to the next question. If a force of 9 Newton is acting on the body, then find the instantaneous power supplied to the body when the velocity is 5 in the direction of the force. I mean, isn't this direct question? The question is to find the instantaneous power, and power is nothing but force into velocity. Force is 9, velocity is 5. So directly 45. This was Laddu question. 45 watts. 45 watts. Just check option B. Yes, B for Basvasaurus. So in this particular question, we have velocity which is given by k root x. Is that right? K root x. So velocity is nothing but dx by dt. That is nothing but k root of x. Root x, I can also write it as x raised to half. So bring it on the other side. So it will become x raised to minus half. Dx is equal to k into dt. K into dt. Integrate on both sides. So integration of x raised to minus half dx is k integration of dt, 0 to t, this will be 0 to x. X raised to minus half integration, minus half plus 1 is plus half. So divided by half, limits I have to put 0 to x, this will be k, and then this will be t, and this will be 0 to t. So when I integrate this, what will I get? I will get x 2 on the top. So 2 root x I will get. So I'll get 2 root of x is equal to k into t. Okay. So from this, I'm just getting the value of root of x as kt by 2. Now, why am I finding root of x? Because it will be useful over here. So I can find the value of x also if you want. Okay. Now, why is this important? Because this will give me the x at time t, the x at basically time t, and that is needed for solving the question because it says you have to find the work done. Now, what is the work done? Work done is basically change in the kinetic energy. Change in the kinetic energy. Is that right? Work done can be found by change in the kinetic energy. So it will be half m final velocity square. It starts moving. That means initial speed was 0. So initial energy velocity is nothing but k root of x whole square. Velocity is k root of x whole square. But wait a minute. I can see this will just become root of, this will just become k square. This will just become k square. And then I have root x over here, root x over here, root of x over here, and that also has been squared. What is root of x? I can see it is basically root of x is nothing but kt. Why is this happening double times? Kt by 2 and then the whole square. Is that right, everybody? Okay. So what is this coming out to be? Half m k square. K square into k square is coming over here, and then there is this t square, and 2 square is nothing but 4. Everyone fine till this point? Okay. Now what is this? K square into k square is k raised to 4. So m into k raised to 4, then t square, t square, and then we have 2 into 4, and 2 into 4, which is nothing but 8. So m k raised to 4 t square, not divided by 4 but divided by 8. So it should be C option, but I think A option was marked by mistake, so that is definitely then wrong. Yes, so this is actually correct, option C. A body is being moved from rest along a straight line by a machine delivering constant power. The distance covered in is proportional to which power of the time? Which power of the time? If the power is constant, constant power, power is a constant. Power is force into velocity. So that is a constant. Force is nothing but mass into acceleration. So m dv by dt into velocity is a constant. So I can do this. Velocity into dv is c by m into dt. So what I can say, integrate v with respect to dv. C by m is one more constant. Integrate dt 0 to t. This will be 0 to v. V's integration is v square by 2 minus, again put the lower limit, 0 square by 2. That constant dt's integration is t. So put first t and then put 0. So I will definitely get v square by 2 is equal to c1 into t. I can put that 2 on the other side. It will become one more constant. V square is c2 multiplied by time. Or I can just say it is 2 times c1 multiplied by time. Therefore, v will be root of 2c1 multiplied by t raised to half. Now, this particular velocity, I can then write it as dx by dt. This is a new constant. I can call it new constant c2 into t raised to half. Take that dt on the other side. So dx will be c2 into t raised to half into dt. Oh, now integrate. Integration of dx. c2 will be outside. T raised to half's integration with dt. Integration of dx is x. c2 is some constant. T raised to half's integration is t raised to 3 by 2 divided by 3 by 2. So the power to which x is proportional to is 3 by 2 times raised to 3 by 2, t raised to 3 by 2. Yes, option number B, correct. Lovely question, right? The constants didn't matter. You just had to see the proportionality. Whatever constants were there, just ignore it because we just had to see what is it exactly proportional to. Nothing more was needed. Next one. Particle goes in unidirectionally on a horizontal plane under the action of a power supplying energy source. The displacement time graph that describes the motion of the particle. Guys, the same question was asked in a graphical way because from the previous question we got x is proportional to t raised to 3 by 2, t raised to 3 by 2. That means it should be a curve which is increasing. There is a curve which is increasing. It can't be a straight line. So it can't be this, it can't be this, it can't be this, it has to be this. So displacement proportional to t raised to 3 by 2. So option B should be correct. Yes, it is B option. Cool? Yeah. These integration questions are like devils. Mamta, practice many integration and derivative based questions. Do not think it will not come. And those will be the killer questions that will decide whether you get into AIMS or not. See, everything which is difficult for you will be difficult for everyone. Only those people who challenge that difficult questions and practice those questions will get into a good government college like AIMS, AFMC, yeah, or your local government college. Otherwise, you will be like everyone and you will probably have to pay heavy fees to get into a private college. So let's avoid that. Whatever is difficult, practice more questions. It will not be difficult for you. Let it be difficult for everyone else who is not watching the video. Okay. So a particle of mass m undergoes acceleration. The speed is t. The power delivered is how much? Okay. Power is asked. The power is asked. Power is force into the velocity. That is one way to do it. But the velocity is keeping on changing. So what is the best way to do it? What is the best way to do it? Power is work done upon time. Work done upon time. That is another way of doing it. So how do I write the work then? Work divided by time. Work is change in kinetic energy. Oh, now I get it, sir. Kinetic energy finally will be half mv square. Initially it was 0 divided by time. So it will be mv square by 2 times of t. mv square by 2 times of t, which is D option. Check it out. Definitely. So very nice question on power where you have to use work by time. Usually you do not use this formula. Usually you use F into V, but sometimes work divided by time also can be used. And how we have also correlated work with change in kinetic energy using the work kinetic energy theorem. Work kinetic energy theorem. Next, there are two objects, mass m1, m2 having same momentum. Okay, the ratio of the kinetic energy is, okay, same momentum, ratio of kinetic energy is asked. Kinetic energy is momentum square by 2m. So kinetic energy is inversely proportional to m. So k1 by k2 is m2 by m1. That's it. m2 by m1, nothing more. Is it option D? Default doctor, check it out. Very good. Excellent, Jinendra. You read books, Ninja, Siva, Roshni. Very good, guys. Very good. Awesomeness. Awesomeness. Let's go to the next question then. I think not many questions are remaining. Few questions only. Two discs, same mass, same thickness, densities are given. Ratio of their moment of inertia about their axis will be. Say moment of inertia for a disk is mr square by 2. But the discs are of the same mass, same thickness, radius, nothing is mentioned. They're just told thickness is same. So I need to be little bit careful over here. See guys, the total density is mass divided by volume, and the volume is pi r square into thickness. So therefore, our r square will be mass by pi rho t. Take r square on the top, take rho below. So r square will be m by pi rho t. So I'll just put that over here, m by pi rho t over here, and this is m divided by 2. Okay, perfect. Everybody fine till this point? Density was mass by volume. Volume is area into thickness, right? I hope you understood that part, because this is a disk. It looks like a cylinder. There will be some thickness. There will be some radius. So volume of a cylinder. Okay. So now from this, we can see very clearly that the moment of inertia is inversely related to the density. Thickness is same, mass is also same. So I1 by I2 will be rho 2 by rho 1, rho 2 by rho 1, which is 51 by 17, which is 3 by 1. So 3 is to 1 should be the answer, or 1 is to 3 will be the answer. Okay. So I think it should be I1 by I2 will be 3 by 1, not 1 is to 3. It is going to be inversely related. Is that clear? Yes, 3 is to 1 should be the correct answer, guys. 3 is to 1 is the correct answer. I think they have given 1 is to 3, which is wrong. Okay, moving on to the next one. A small mass is attached on a to a string, and it is rotating on a smooth table. Tension in the string is increased by pulling the string, so the radius decreases by a factor of 2. What will happen to the kinetic energy? Very good question. Middle break not there. Hardly few questions are there. 5 to 10 questions might be there, guys, not more than that. Yeah, 5 to 10 questions will be there, I think. Let's see. First of all, in this particular question, you know what is happening? When you pull the string, the radius reduces, so the speed will change. And why is it changing? Because conservation of angular momentum. Yes, conserve angular momentum. Conserve angular momentum. So in this process, mass into velocity into radius will be mass into the radius has been decreased by a factor of 2. So the final velocity into final radius. So you will notice mm gets cancelled, v into r, because the radius has been decreased by a factor of 2. It will be r by 2. R cancels, and your final velocity will be double of the original velocity. So with this we get, since kinetic energy is proportional to the square of the speed, the final kinetic energy square of 2 is 4, 4 times of the initial energy. Hence, increases by a factor of 4. That should be option A. Conserving angular momentum. Angular momentum formula is MVR, right? Awesome question. Very different type of question is asked. Next one. In this diagram, there is a meter scale of wood while the other half of steel. The wooden part is pivoted at point O. A force F is applied at the end of the steel. In second diagram, the steel part is pivoted, the wooden part, you are applying the same force. Then who will have more acceleration or same acceleration or incomplete information? This is very nice question. Out of wood and steel, who has more mass, more density? Think and tell me, assuming same blocks. Yeah, assuming same blocks, who has more density? Obviously, steel has more weight, more mass, more density. So this is basically heavier. This is basically heavy. So when you rotate about this, the heavier part is at more distance, is at more distance. So definitely the moment of inertia is going to be higher in this case. Moment of inertia is higher in this case. Compare it over here. The heavy part, the heavy part of it is pretty much close to it. So the moment of inertia is going to be less. Same force, same distance, same force, same distance, which means what? The torque is the same, and torque is moment of inertia angular multiplied by angular acceleration. So if you compare now, because the torque is same, the one with higher moment of inertia will have lesser angular acceleration, and the one with less moment of inertia will have higher angular acceleration. That's the logic behind it. So more acceleration will be produced in which case? Obviously, it will be produced in the second case, because the heavier mass is closer. So less moment of inertia. So higher acceleration in the second case. Not B, sorry, not A, it will be B. Teja, Ninja, I hope that clarity you have got. Yes. So in the first part, A had more density, but it will have more inertia. That's why less acceleration. Cool. Okay. Moving on to the next one. 3-point masses placed at the vertices of a triangle, moment of inertia of the system about COD, this line. Okay. So basically, this mass will be going along this particular circle. This will be over there only. This mass will be going along a much larger circle. That mass is over there only. So just need to know what are the distances, you will get it. First mass has a clearly mentioned distance of A. How much distance will this be? Well, this is an equilateral triangle. This is 60. So naturally, this will be 30 degree. So this distance will be hypotenuse is A. So sine 30. So A sine 30 is half. So it will be A by 2, I believe. A by 2. So now I can find the total moment of inertia. This guy is at 0 distance. So M into 0 square. This guy is at A by 2. So M into A by 2 square. Last mass M into A square. So this will become M A square by 4 plus M A square. 4 plus 1 is 5. So 5 by 4 M A square. Is that absolutely clear? Yes. Guys, I'm turning off the lights because my UPS is beeping now. So unfortunately, I cannot keep on the lights because the light will go off at any moment. So I'm just trying to take the class in little bit dark mode. So Shreyas sir in dark mode. Yeah. Shruti, which part? Thank you, Kavyasri. Yes, we are doing it unit wise now, Kriko. And the chapter wise practice is going to happen in the crash courses, the PYQ sessions, everything is happening in the crash courses. So you better be a part of those revision batches. Yeah. So in this particular problem, what happened is this mass will go in a smaller circle, this mass will go in a big circle. So if you know the radius of those circles, you can find the moment of inertia. To find the radius of this guy, this is an equilateral triangle having 60. So this angle will be 30. In this right angle triangle, this is opposite to 30. So it will be the sine component of the hypotenuse. So hypotenuse is A. So A sine 30 will be the opposite side. If it is adjacent, it will be the cos component. Is that okay? Clear? Shall we go ahead? I know it's completely dark. You will not be able to see me. I hope my voice is audible. My voice is audible. Okay. So unfortunately, the current has taken over and there is no electricity now. So even my board has turned off. My board has turned off. So there are, I think, around 5 to 6 questions only remaining. I'll be sharing the PDF with you. Okay, I'll be sharing the PDF along with you. So please download that PDF and solve those remaining 5, 6 questions. Okay, I'll put up the solution also for them. All right, cool. So we have almost completed all the questions. So sorry guys for the, whatever, that current